about the shell sort. So this is also one of the sorting technique in the data structure. So there are actually two types of sorting techniques in the insertion sort. Okay, that is a simple insertion sort and shell sort. So if you want to know about the simple insertion sort, so I am going to provide the link below the description box. Okay. So shell sort is also a part of the insertion sort. So it is also a improved version of the insertion sort. The insertion sort works very well when the input elements are partially ordered and the numbers to be sorted are very less. Okay, so this is a combination of actually insertion and bubble sort. Okay, so how we will insert the elements in the insertion sort. So we are going to take one element from the unsorted zone and place it in the appropriate position in the sorted zone, right? And in the case of the bubble sort, we are going to swap the elements which are adjacent to the bubbled element in the array, right? So we are going to combine these two techniques in the shell sort. So this technique was invented in 1959 by D.L. Shell and hence the name is shell sort. So this technique is similar to a simple insertion sort. So instead of comparing the adjacent elements one after the other as in the insertion sort, far apart elements with equal distance are compared. So here we are going to consider the gap. So for the array of elements, so let us consider the elements in the array with the length 10. So if you want to find the gap of the array, okay, so we have to use the formula here, floor of n by 2. So n is the size of the array. So here the size of the array is 10. So 10 by 2 is 5. Floor of 10 by 2 is 5. So we are going to consider the gap between the elements to be compared is 5. And some subfiles are generated with this gap as given below. Okay. So here the subfile 1 with the a of 0 and a of 5. Okay. So we have to compare the elements at the position a of 0 and a of 5. Right. So in the subfile 2 we have to compare the elements here a of 1 and a of 6. So a of 2 and a of 7. A of 3 and a of 8. So similarly here a of 4 and a of 9. Okay. So we are going to have to calculate the gap of the array at each and every pass of the sorting technique in the shell sort. So based on the gap, so we are going to perform the sorting. Okay. So here we have to swap the elements at 0 and 5th position. Okay. So we are going to swap. So here the 21 is less than 77, right? So we are going to swap these two elements. So similarly, a of 1 and a of 6. So 1 and 6. 62 is greater than 80. So this is in the correct position. Okay. And then we are going to consider the subfile 3, that is a of 2 and a of 7. So a of 2 and a of 7. 14 and 25. So these are in the correct position only. Right. So like this we are going to compare the elements at the subfiles. And then we have to produce the new array of elements for the second pass. So here each subfile is sorted using the insertion sorting technique. So now reduce the gap between the elements to be compared by 1. So generate the subfiles and sort these files based on this technique. So repeat the same process each time by reducing the gap. So finally if the gap is 1, then it will work as a simple insertion sort and the final output obtained will be the sorted array. So here it works similar to the bubble sort. So in the bubble sorting technique, so we are going to bubble the element and compare it with the neighboring element, right? So instead of comparing the element with the neighboring element, we are calculating the gap for each and every pass and we are comparing the element with the particular gap. So here the gap equals to n by 2, that is 5, right? So 77 and then 21. So here is the gap 5, right? So 1, 2, 3, 4 and 5. So gap is 5 between the 77 and 21. So we are going to compare these two elements. Okay, so 21 is less than 77. So we are going to swap these two elements here, right? So So similarly, so for the 62, so what is the gap? 62 is marked with blue mark, right? So 1, 2, 3, 4 and 5. So 62 and 80. So these two are the correct position only. So we will leave it. So next coming to the 14, right? So what is the gap here? 5. 1, 2, 3, 4 and 5. So 14 and 25. So these two are also in correct position. That is in ascending order only. So next coming to the 9. So after the 9, 1, 2, 3, 4 and 5. So 9 and 70. So these are in the correct order. And next coming to 30, right? So 30 with gap 5, 55. So 30 and 55. So these are also in the proper order. So there is no need to swap. Okay. So next in the second pass, so this is the new array of elements. So now again we have to calculate the gap for this newly generated elements. Okay. So here gap equals to f of n by 2. So here we have to consider the previous gap of the array. So we should not consider the size of the array here. So we have to consider the previous gap. So what is the previous gap here? 5. So 5 by 2 is 2. So floor of 2.5, right? 5 by 2 means 2.5. So floor of 2.5 is 2. So we are going to consider the compare and swap the elements with the gap 2. Okay. So 21. So 1, 2. So 14, right? So we have to compare the elements with the gap 2. So 21, 14, 30, 80 and 70. Okay, remaining elements are, so this is one gap. So another gap is 62, 9, 77, 25 and 55. Right? So here so first order is 21, 14, 30, 80 and 70. Okay, so these must be arranged in a proper order, like in insertion sort. So here we are going to use the two techniques, right? Bubble sorting technique and insertion sorting technique. So here in the first pass, if you observe 77 and 21, so these are the only two elements in the subfile 1. Right? In the subfile 2, we are having two elements. Right? In each and every subfile, we are having only two elements here. So that's why we are performing like in the case of the bubble sort. Right? How we compare and swap the elements, like this we are going to apply the bubble sort and insertion sort here. But in the second pass, we are having 5 elements here. So what are the 5 elements in the second pass? That is 21, 14, 30, 80 and 70. 80 and 70. So these are the remaining elements, right? So we have to arrange these elements in the correct order, that is in the ascending order, using the insertion sort, right? So 14, 21, 30, 70 and 80. So this is the proper position. 30, 70 and 80. Right? So this is the proper position. So right. So 14, 21, 30, 70 and 80. Right? So next one is the 62, 9, 77, 25 and 55. So these bubbled elements must be swapped, right? So bubbled elements with the red color is swapped. Okay, so by using the insertion sorting technique, so we are going to arrange these elements in ascending order, right? So insertion sort means it will place the element in a particular order. So we are applying the insertion sort. So if you want to know about the insertion sort, you can watch my previous video. So 9, 25, 62, 77 and 55. So this is the next order. So in the subfile 2, we are having the 9, 25, 55. So here I have not arranged this. So 55, 62 and 77, right? 62 and 77. So these are in the subfile 2. So subfile 1 elements are this and subfile 2 elements are this, right? So in this manner we can arrange the elements using both the bubble sort and insertion sorting techniques. So next, what is the gap here? Okay, gap equals to f of n by 2. So n by 2 is 2. 2 by 2 is 1, right? So here the gap is 1 for the next array. Okay, so what is the gap here? 1. So that means we are going to swap the elements, that is the neighboring elements, right? So 14, 9, 9, 21, 21, 25, 30, 55, right? Like this manner we are going to swap the neighboring elements. Okay, so 9 and 14, so 9 will come in the front and 14, right? So next 14 and 21 will be compared, so 14, 21, 21, 25, so 25. So like in this manner we are going to swap with, compare and swap with the adjacent elements. Okay, so this is the final output. Okay, so this is the how we apply the shell sorting technique here. So by using a formula, gap equals to f of n by 2. So in this sorting technique, instead of comparing the adjacent elements as an insertion sort, the elements with an equal gap or equal distance are compared. The simple insertion technique is used with an exception that the distance between the elements to be compared is same. So the first version of the algorithm is like in this manner. So how we will implement the gap sequence using the shell's original sequence. So there are different ways to find the gap difference sequence using the for the shell sort. So that is the shell's original sequence, that is the gap equals to n by 2. So this is the original sequence. And Knud's increment, okay, Sedgwick's increment, Hibbert's increment, Papernow and Pratt increments. So these are some of the different types of sequences that we can use for obtaining the shell sort. So if we consider the shell's original sequence, that is the gap equals to n by 2, n by 4, n by 8, like in this manner we can consider. If you consider the Knud's increment, so the order will be 1, 4, 13, so and so on. That means we are going to select the elements in the order of 3 power k minus 1 by 2. K minus 1 by 2 for the Knud's increment. That means, so we are going to select the first element, fourth element, 13th element. So in this manner we are going to select for the Knud's increment. For the Sedgwick's increment we are going to consider 1, 8, 23. So we are going to consider the elements at the first position, 8th position, 23rd position, like that. Okay, so like that we are having different types of sequences to find the gap. But here we are using only the shell's original sequence. And coming to the best case, average case and worst case of the shell sort. So best case is big O of n log n, and the worst case is big O of n square, and average case is big O of n log n. So it is not a stable algorithm. Okay, and some of the applications of the shell sort is calling a stack. Okay, calling a stack and the recursion. Okay, in the stack calling and recursion we are going to use this shell sorting technique. So this is about the shell sorting technique, and thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.